Welcome all of you. Today's video is related from enzyme kinetics and inhibitor portion. So the question which I have taken today is question number 12 from 2013 Life Sciences paper from biochemistry section. So this question states that the following figures show the plot of reaction rate versus substrate concentration for an enzyme catalyzed reaction in the presence and absence of inhibitor. Match the following possible reaction types with the plots. So there are four plots given and four options are also given to us. So first plot, if we'll see, here we can see that it is a plot between rate of reaction versus the substrate concentration. Okay, versus substrate concentration. Okay, so here we can see that as the substrate concentration is increasing, the rate of reaction is also increasing linearly. Okay, so there is a linear equation between the substrate concentration and rate of the reaction at smaller concentration. However, when it reaches, the rate of reaction reaches to the maximum velocity, it follows a hyperbolic curve where we can see that once it reaches to the maximum velocity, increase in the substrate concentration will have no effect on the rate of reaction. So once the velocity of the reaction reaches to the maximum point, adding more substrate to it will not increase the rate of reaction because all the sites of the enzyme are not occupied with the available substrate. Okay, so this is the saturation point of the enzyme. So this is the Michaelis-Menten plot. Okay, and here also we can see at half of the maximum velocity, the concentration is given, which is called as Michaelis-Menten constant or Km, and this Km is also referred as the substrate concentration at which the rate of reaction is half of the maximum velocity. Okay, so this is a typical Michaelis-Menten graph which we can see in the first plot. So out of the four options, the third option, which is R, is the matching with the first graph, which is Michaelis-Menten graph. Okay, now if we see the second graph, so we have our second graph where we can see that the rate of reaction started increasing. However, after a certain peak, it again got decreased. Okay, so here we can see that the rate did not reach to the maximum velocity. Okay, so it could not reach to the maximum velocity. So here, is there any inhibitor added? I don't think so, because whatever possible explanation of inhibitor we have, it does not fit there. Okay, it is reaching to the maximum velocity to some extent and they again going downwards. So this is a phenomenon of substrate inhibition. So without adding any inhibitor, in some reaction, substrate inhibition phenomena will take place, where what happens that in high concentration of substrate, two molecules of the same substrate compete for the binding site on the enzyme, and there it reduces the rate of reaction and doesn't allow it to increases. So these kind of phenomena we can say in case of bioreactors. So in high concentration of substrate itself inhibits the rate of reaction and it goes downwards. So this particular plot represents the this particular phenomena, which is also called as substrate inhibition. So Q follows our second plot. Now we have our third plot, which is of So this third plot where we can see that Vmax has been achieved. However, when we can see that the concentration here changed from 1 millimolar to 2 millimolar. So here 1 millimolar we said that it is the Km value or the Michaelis-Menten constant. So here we can see that Michaelis-Menten constant is increased. However, the Vmax remains the same. So this happens in which case? So we have three kinds of inhibition example: competitive inhibition, uncompetitive inhibition, and non-competitive inhibition. So in competitive inhibition, what happens? In the enzyme we have the active site where the substrate can bind, okay, and substrate and enzyme both are of the similar structure, both have the similar structure, okay. Substrate enzyme both have the similar structure and they can bind to the same site of the substrate, enzyme, same site on the substrate enzyme. So here either substrate can bind or inhibitor can also bind to this particular site, binding site on the enzyme. So that causes decrease in the Km value. Okay, so Km is indication of the affinity of enzyme towards the substrate. So in presence of inhibitor which binds to the same site as of substrate, reduces the enzyme's affinity towards the substrate. So here what happens, when we increase the substrate concentration, the binding affinity or the of inhibitor goes down because there is a competitive inhibition. So more concentration of inhibitor replaces the substrate from enzyme and more concentration of substrate removes the inhibitor from the enzyme's active site. So in case of more concentration of substrate, inhibitor will be removed and substrate is now able to bind to the enzyme and allow the progress of the reaction. So in this scenario, the Km value increase because now we need more substrate so that it can effectively bind to the enzyme. So Km value increases in case of competitive inhibition. However, the maximum velocity still reaches the same value. So that is why in case of competitive inhibition phenomena, Km value increases, however Vmax remains the same. In this graph also we can see the similar thing which is happening. From the Km value increases from 1 millimolar to 2 millimolar, however the Vmax remains the same. The reaction is still able to reach to the maximum Vmax value. So our third plot is matching with the phenomena P, which is competitive inhibition. So P is matching with the third plot, which is competitive inhibition. Okay. Our fourth plot, if we'll see, so here what we can see, here also we can see half of the maximum velocity is at 1 millimolar. That means the Km value remains the same, which was given here. Different from this value where half of the maximum velocity was achieved at 2 millimolar concentration. However, here half of the maximum velocity is still able to reach as the 1 millimolar concentration. But we can see that this reaction is not able to achieve to the maximum value. It only reaches to the 2/3 of the maximum value. So this kind of phenomenon takes place during the non-competitive inhibition. So in non-competitive inhibition, what happens that this is the enzyme so the inhibitor can bind to the free enzyme as well as it can bind to the enzyme substrate complex. Okay, so as we saw in case of competitive inhibition, substrate and inhibitor were binding at the same site. However, in this non-competitive inhibition, substrate has some other site where inhibitor can bind. So substrate bind at the normal site, active site only, however inhibitor binds to the other site, which is also referred as allosteric site. And this binding of inhibitor to the allosteric site causes some configurational changes which affect the rate of reaction. So in this kind of inhibition, the Vmax value cannot be achieved. So here the Km value has no change. So the Km remains the same. However, Vmax value decreases. Okay. So this kind of phenomena is found in non-competitive inhibition, which we can see in the graph that the Km value, like at the value at which the rate of reaction is reaches to the half, it's still the same, which is 1 millimolar. However, the Vmax value is decreased, which is matching to the non-competitive inhibition phenotype. So the fourth plot is matching to S phenomenon. Okay. So if we'll see our second option, where P is third, Q is second, R is first, and S is fourth. So this B option is our correct option. Okay. So to understand more about enzyme inhibition and the detailing about the enzyme inhibitor kinetics, you can refer to this NPTEL course, Enzyme Science and Technology by Professor Vishal Trivedi. Lecture number 43, enzyme inhibition. Part 1, part 2, both you can read in detail and understand the concept. Thank you.